Okay, let's compare and contrast our angular terms with our translational terms. So I want to talk about delta theta versus delta x. I want to talk about angular speed versus translational speed, v tangential. I want to talk about angular acceleration versus translational acceleration. And so what you have here in general is that these terms over here, these are all vectors. These terms over here are not vectors. That's because the terms on the left, they may have a magnitude, but they don't have a direction that's easily defined. I mean, the direction for angular speed is always changing. If you have, for example, if we were to look at this turntable example from this week's exam review questions, we have these two bugs, and they're going around this. We can call it a record player or a merry-go-round if we had a bug-sized merry-go-round, and they're both moving around in a circular fashion here. But while they will have a v tangential equal to omega times the radius, which is going to be a vector, they will not have an angular speed that is a vector. It will only have a magnitude. Now, one of the most interesting things about these angular terms is that we do tend to assign signs to them. For example, this turntable is moving like this. So it's actually moving in a counterclockwise direction, which we represent as positive, right? And we also know that if it had moved in a clockwise direction, we would assign this a value of negative. So we do not make these vectors, but we can assign signs to them. So don't let that throw you off. Just because we assign a sign to it doesn't mean that it is a vector.